we have James Eastham with us today to talk about event-driven architectures and everything there is to know about them. This is the first live stream of March where we're going to be focusing on EDA, and I think James is going to be laying down the groundwork for us. So without further ado, James, take it away.
Thank you very much, Alan. In his best-selling 2014 book, Homo Sapiens, Yuval Noah Harari discusses a brief history of humankind. And one of the most important points he has in this book is the importance of stories. Stories and words are the master key that unlocked human potential, whether that be your religion, the nationality you're part of, or the company you work in and their mission and their values. The ability to communicate an idea, get people behind it, and get people involved is really fundamental to something that differentiates us from animals. Now, if anybody's just rolled in late or is feeling extremely confused by now because they think this is a talk on event-driven architecture, I promise you it is. And that's because event-driven architecture is fundamentally a communication pattern, a way of modeling the integration between your systems. And that might be the technical communication, one service talking to another, but that also might be the human communication, describing what it is that a system does. The language, the story of your business is driving its technical implementation and its functionality. And that's what you're going to learn about in this talk. You're here to learn the secrets of event-driven architecture, how you can build event-driven systems from basic concepts through to some more intermediate and advanced patterns. I'm James Eastham. I'm a senior cloud architect at AWS. I'm a serverless advocate, .NET developer for my sins. And I want to set the expectation really early on that this is not going to be a talk about AWS services, about AWS implementations. This is a really simple talk that's about really simple boxes and lines. Yes, it's one of those kind of talks. And I want to start by being really, really honest with all of you listening now. I've built event-driven systems in the past, and they've gone horribly, horribly wrong, which might make you think, why am I wasting my Thursday listening to someone who doesn't actually know how to build event-driven systems because they've failed so many times? He's just admitted it on a live stream. One of my old mentors always said to me, it's failures that build experience. You learn so much more in failure than you do in success. So that's what I want to walk you through today. Some practical tips and things that I've learned from getting it badly, badly wrong. So hopefully you don't get it badly, badly wrong in the same way. Now, if anyone has seen me talk before, you'll know that there's one thing I love talking about as much as .NET and serverless and event-driven architecture. That's, of course, pizza. And so for the rest of this talk, you're all going to have a task. You're going to introduce an event-driven architecture to a completely fictional pizza delivery company called Plant-Based Pizza. And you've already adopted microservices. All your inter-service communication currently happens using HTTP APIs. This is your architecture today. And as you can see, all of your services need to know where all of your other services are. The order processing service is at the core of the system. It's your core domain, and it's the fundamental piece that gets all of your application working. Because, of course, if people order pizzas and they don't get their pizzas, then people will be very, very sad. And this order processing service has explicit dependencies to the delivery service, to the kitchen, to the pickup service. And now you need to add an additional service to support loyalty points. The challenge with this is that all the order processing service needs to know where all of these different services are at runtime. It needs to know the location of them. And that, of course, is a form of coupling. And I'm sure many of you have heard the general rule of thumb in software design, which is to aim for low coupling and high cohesion. Now, cohesion is a relatively straightforward one. Things that change together live together. And you already have pretty high cohesion in your architecture today because you're building with microservices. You've broken your system down into these small, independently deployable units. The functionality that is changing together is now being deployed together. Coupling, however, is a little bit more nuanced. And it's nuanced because there's lots of different types of coupling. You've got technology coupling. Are you using Java, .NET, Rust, Python? You've got temporal and data format and location coupling. Where is your service? What's the IP address? What's the domain name? You've got data format, semantic coupling. Are you using binary, JSON, protobuf? How do you handle null values? What casing are you using in your JSON payload, camel case or some weird underscore based naming convention? Some of these are a lot more tricky to deal with than others, and HTTP communication in microservices is typically dealing with runtime and location coupling. At execution time, at runtime, when a service is running, it needs to know about all the location of all these other services that you need to work with. Now, of course, without some element of coupling, if you completely decoupled all of these microservices, you wouldn't really be able to get anything done because they need to work together. So what you want to aim for is an appropriate level of coupling based on your use case. And I really like this quote from Gregor Hoppe. I think every single time I talk about event-driven architecture, I have this quote somewhere. The appropriate level of coupling depends on the level of control you have over the endpoints. And what I think Gregor means here is that if you imagine you're a team building 3 or 4 microservices, they're in the control of your team. Coupling them services together more tightly might not necessarily be the worst idea in the world because you control the release cycles, you control the SLAs, the schemas of these APIs. But once you're integrating with something outside of your control, a third party, another team inside your organization, you want to try and lower that coupling as much as possible. So if it's coupling that's causing all of our problems here, why does it help to be event-driven? What benefit does that actually give you? Well, as of right now, you need to create this new loyalty point service. And whenever you do that, whenever you want to make a change in your system, you also need to make changes to your order processing service. And it's becoming really, really frustrating because somehow, somewhere, you're always dependent back on the order processing team. And actually, when you think about this, should the order processing service actually care about the fact that people are collecting loyalty points? Is it the responsibility of the order processing service to tell the loyalty point service when it needs to add some loyalty points? And you could probably make that same argument for some of the other services as well. I don't think it really is the responsibility of the order processing service. The other challenge I have here, possibly the more obvious one, is that because of this coupling, a failure in your loyalty point service, something completely off the critical path of your application, could actually have a knock-on effect of taking your order processing service offline. And of course, this applies to other areas again. If the kitchen is offline, should that stop you collecting orders? I realize I'm oversimplifying that massively. There are ways you can build microservices that handle all of these problems: circuit breakers, backoffs, proper error handling. Just because you're building microservices in this way doesn't mean you're going to build an unstable system. However, if this is why you want to be event driven to help reduce some of this, what does it actually mean? What does the word event driven mean? And one of the best ways I found of describing this is actually something I've taken from one of Martin Fowler's talks on the topic of event driven architecture. At its core, Martin says that event driven architecture is about reversing dependencies, reversing the lines of integration. So now your order processing service doesn't need to know anything about all the other services consuming from it. And by the end of this talk, you're going to have made this entire order processing flow event driven. But before we get into that really practical stuff, let's just get a little bit more theoretical for a second. And I promise this will be quick, just to make sure we've level set on some of the key terms and things that we're talking about here. And the first one is, what actually is an event? How do we describe what one is? Now, in my opinion, an event is an immutable fact. It's something that has happened. It can't be changed. It's just a notification that something has happened somewhere else in your system. An example I like to use here, and this analogy is a bit of a stretch, so bear with me, is around light switches. So imagine you're at home, it's the middle of the night, you get up and you need to go and do something in your house and it's dark. And you want to make sure that you don't step on any Lego bricks that someone else in your house accidentally managed to leave on the floor in front of you. So you go into the room, you hit the light switch, and that's going to raise a light switched on event. And you can't, at that point, unswitched on a light. That has happened. It's irrefutable. There's light in the room. You can avoid the Lego bricks. And then when you leave the room, you're done in the room. Or if you're just playing crazy and want to play Lego brick bingo, then you can hit the light switch again, and that'll raise a light switched off event. Again, it's happened. You can't change it. The light is now off, and you're now at risk of stepping on Lego bricks. So if that's the definition of an event, what does it actually mean to be event driven? And I think there can be a little bit of confusion here between event driven systems and systems that just use events to process some kind of functionality. And I realize it feels like I've said the same thing there. In an event driven system, it's business events that are triggering your functionality. Events have been used in software development for years. I first started building systems in .NET and Windows Forms, a desktop-based way of building .NET applications. And when you built Windows Forms applications, you could react to button-clicked events, or Windows resized event, or window hovered events. And if you think about more modern ways of building systems, you could even apply this to things like S3 object created events. These are things you can react to. They're events, but they're technical events, not business events. Business events are things like order placed, pizza boxed, staff member clocked in. The way I like to think about this is that if you looked at two businesses in the exact same domain, two pizza delivery companies, both building event-driven systems, they would have potentially two completely different sets of events. However, they might have some similarities in things like S3 object created or button clicked. And this comes back to this idea of stories. It's one of my favorite parts of event-driven systems because an event-driven architecture lets you tell the story of your business through its technical implementation. So there's something else you will commonly hear when you hear about event-driven systems, and that is that events are first-class citizens. And you might read that and go, huh? Well, what does that even mean? With as well as these events being based on your business events, you should also treat your events like an API. I'm sure many of you listening will be familiar with the idea of API first design. The idea of API first design is the first thing you do when you start developing a new system is you design its API, you design its interface. And then when it comes to you integrating two systems together, you have an agreed contract, something that you agreed on that you can work to. So making events first class citizen means focusing on event first design. Your event schema, the structure of your events, is your API in an event-driven system. That's the contract between your services. It's the language that your services use to talk to each other. It's also the language that you use as a human to bring the business into your systems. And when you're thinking about events, it's not as simple as just having events. There are different types of events that you might see. Whilst you might initially think that these events are just immutable things that you're passing around asynchronously, it can be a little bit more nuanced than that. And it's really important to get this right because how you structure your events can be a deal breaker for the success of your system over time. And the first type of event you'll commonly encounter is a notification event or a thin event. These are simple, small packages of data that simply notify something's happened between two systems. And this is where you actually go ahead and start with your first implementation of EDA in plant-based pizza. You start with this integration between your order processing service and your kitchen. So the order processing service publishes an order confirmed event, and the kitchen service is listening for that event. The kitchen service receives that event and it's like, yes, I've got a new order to create. Somebody wants pizza, exciting. And then the kitchen service goes, I don't actually know what's on this order. All I know is that an order has been confirmed. So what I'm going to do, I'm going to reach back. I'm going to call back to the order processing service, and I'm going to find out what details are actually on that order, what I actually need to prepare. And this is a pattern I've built before. I've built this exact system. Publish an event, call back. It wasn't pizza. That was kind of sad. And we celebrated when we first built this. We're great. We're event driven. We're doing events and we're passing them around, and that's triggering functionality. But then actually, is this really any better? Because you're still coupled, you're still dependent. And then what happens when you get one more subscriber to that order confirmed event? And then another three, and then some more, and then an initial one, and then another whole load of event systems that spin up, all interested in this order confirmed event, all reaching back to get more information. But what happens at this point is obviously absolute chaos. Because a core principle of EDA is that services are unaware of their downstream consumers of their events. So whilst this pattern works from a functional perspective, you do open up your event producer to having to handle all these callbacks to get additional information about events. So that might lead you to think, is there a better way of handling this? What are my options, James? And the solution here is the second type of event that you will commonly see, and that is event carried state transfer, or also known as a more fat event. And if you consider this being your notification event, I couldn't resist getting a little bit of .NET code in here. For any non-.NET developers, I also made this JSON. So this is an example of your notification event. It's an order confirmed event that simply includes the order ID that has been created. And then this is what that same event might look like as a fatter event. You see that the state of the order is passed as part of the event payload. And that now means that any consuming service has all the required data it needs to actually do any work that it needs to do. Which one is the right one to choose? Hold that thought. We're going to come back to that in just a minute. Just to round out this more theoretical stuff, let's just talk about what an event-driven architecture actually looks like, how it actually works. In its simplest form, an event-driven architecture is made up of three parts. You have producers, publishing events, you have consumers, consuming events, and you have something in the middle to stitch these two sets of events together. This might be an event bus. This might also be a queue or a stream. And what you'll notice immediately is that the producer and the consumer have no idea that each other exist. You've almost completely removed that location coupling and runtime coupling. Communication at this point is asynchronous first, and the core integration pattern at play here is the publish subscribe pattern. And not all coupling is removed in this pattern. You still have coupling, the event schema, the contract that you agree on. Well, there's semantic coupling at the schema level. And that's the largest amount of coupling that you're likely to see. And this is why the event schema, the way you design them schemas, is so important, because that's typically the tightest form of coupling you'll still have. And there's a few different responsibilities each party in this system has. As a producer or a publisher, you're responsible for just making sure you stay consistent to the event schema that you agreed on. You, where possible, try and avoid introducing breaking changes, and you conform to that contract that was agreed. And there's some things now that you're not responsible for. You're, of course, not responsible for how your events are used. You're just publishing events, and you don't really care who's using them events. The second thing that you no longer need to care about, especially when compared with HTTP communication, is really interesting, because if you think about when you're building with HTTP and REST API calls, you need to understand the limitations of the system that you're calling. You need to understand the throughput that system has, any authorization that system has, how many requests per second it can deal with. You need to understand all these things. So you need to make that your responsibility, even though it's a constraint of the system that you're calling. When you switch to an event-driven architecture, that responsibility kind of switches around. So now as a producer, you're just publishing an event, and it's the consumer's responsibility to control their own ingestion rate. So as a subscriber in an event-driven system, you need to be aware of the events coming in. You need to control the load against your own system. And this is a more logical way of structuring things, at least in my mind, because now I'm controlling my own load. I'm controlling the events that flow into my system. Now, of course, there's still a possibility that a producer could just publish hundreds and hundreds of events, and then you still overload your own system because you've got hundreds and hundreds of events then flowing into your subscriber. Now, a pattern that can help with that, and one that I always like to do whenever I'm building event-driven systems, is simply to introduce some kind of durable storage at the boundary of your system. So instead of subscribing your application code directly to the bus, you're instead subscribing some kind of durable storage. That might be a queue. And if you think back to Gregor's quote from earlier, the appropriate level of coupling, well, now you've kind of reduced that even further, because you're now not coupled directly to the number of events being published onto the bus. You have this layer of protection, this queue that you can use to manage the load better. And you can also use this to function much like an anti-corruption layer, to validate the events that are coming through, check that the scheme is okay, and generally just being more defensive with your style of programming. The other interesting and slightly more subtle benefit of event-driven architecture, based on the fact that event-driven systems are now using business events, is one of communication. I'm sure many of you have had a challenge in your organization or in your job where you've had to implement a technical solution and you've struggled to have that conversation with a business person who doesn't quite understand what a microservice is or what a REST API is or what an object is. Because now in event-driven architecture, it's your system functionality that's being driven by business events, you can more easily have conversations with people. You can talk to business people and say, what should happen after a payment failed? Or what should happen after an order is confirmed? These conversations get much easier to have to understand exactly what the business requirements are. Because remember, event-driven architecture is fundamentally a communication pattern. It's a way of modeling integrations between systems. One of the commonly touted benefits you'll hear about with event-driven architecture is that of evolvability. Having a central stream of events that any consumer can hook into at any time without affecting any other part of your architecture, it sounds amazing. It sounds brilliant. It sounds lovely. Everything's decoupled. It's fantastic. But actually, you can get yourself into some trouble here, as I have in the past. And this comes back to this idea of thin versus fat events. Let's have a look at this fat event again. What happens now if you need to change the schema of this event? And this is a situation you find yourself in. You've just gone multi-currency. Plant-based pizza's gone global. So you need to start including the currency as part of the order value. And you think, well, it's only the kitchen that's interested in this order confirmed event. So I'm just going to switch this around and I'm going to change the order value instead of just being a decimal to be an object that has a value and a currency. Can any of you see a problem with what we've just done? Remember, you have no idea what your downstream consumers are doing with this data. You might think it's only the kitchen service. And then you realize that there's actually an analytics service that's also listening to this event. You didn't know that the analytics service was using this event. And they're very, very interested in the value of an order. And now you've just broken a system you didn't even know existed. Doesn't sound particularly evolvable to me, right? And this is one of the challenges with fatter events. Because you've got more data in the actual payload itself, you tighten that coupling more than using a thinner event. So now what? And I'm going to put a word on screen now, and it's a really, really naughty word. It's a dirty word. I'm sure you're all going to get shivers down your spine when you read this. Please don't immediately leave the Zoom call. It's important, but it's not very nice. And that word is governance. It's boring. None of us like it. You've always got shivers. I know, I can feel it. It gives you feelings of red tape and bureaucracy, but it's really important as you start to develop event-driven systems. Because of this coupling you have at a schema level, you need a way to govern these schemas. And this doesn't have to be painful. There doesn't need to be red tape here. You can introduce a process that many of you will already be familiar with. And I actually got this idea from a chat I had with Luca Mezzalira. So props to Luca for this one. And that is the idea of using an RFC, or a request for comment process. So whenever you want to make a breaking change to your event schema, you introduce an RFC, you raise an RFC, you get the opinion of other people inside the organization, people who might be interested in this event. And this allows you to stay decoupled and work as independent teams while still keeping an element of asynchronous collaboration and knowledge sharing. And the other thing you can do with your schemas is actually some technical things in the schemas themselves. So as well as introducing a request for comment, you can also introduce some structure around your event schemas. And one of the structures I like to use to do this is the metadata data pattern. This is a pattern of structuring the top level of your event. So you'll notice we've now got this metadata property and the data property. Now, the data property is pretty straightforward. This is the actual event payload. This will be different based on whatever the type of event is that's being published. An order confirmed event is going to look different to a payment failed event. However, the metadata section, that's going to be consistent for every single event that's published anywhere across your system. You can have a same set of properties and fields. The event type, what actually is this event? Order created, order confirmed, payment failed. An event ID. This is a unique, randomly generated identifier that's generated by the producer at the point of publish. And this allows your downstream consumers to do things like add importance, to understand if they've seen this same event before and just drop it if they have. A date and time the event was published. And really importantly for this conversation about evolvability, a version number. Versioning your events is what allows you to more easily and safely make breaking changes. The other pattern you might want to consider in this space is the cloud events specification. So this is a relatively new specification. I learned just yesterday that the CNCF made this, graduated this in February. Thank you very much for that, Alan. This is a very similar idea to metadata data. It's just about having a standard set of properties that all your events have. So you can have these kind of consistent fields, things like versioning and types. So how would you actually introduce a breaking change in practice? Let's consider the same example. Right now, your order processing service is publishing version 1 of your order confirmed event, and your kitchen service is happily working away with version 1. And then what you do in your order processing service is start publishing version 2. And at this moment in time, the version 2 of your event is really, really sad because nobody's interested in it. Nobody cares about it. But it's there. It's being published onto the event bus. And then you let the rest of your organization know that version 2 now exists and they need to stop using version 1 by a certain date, the 1st of April, for example. And over time, all of your subscribers are going to switch over and start subscribing to version 2 of your event. And then eventually you can then drop the stop publishing version 1. Everyone's now using version 2, and you've safely introduced a breaking change. And you've done that in a collaborative way using the RFC process. So to come back to this same question, fat versus sparse events, I wish I could give you a magical silver bullet answer to this question, but honestly, I think I flip-flop on this almost weekly. Sometimes I think sparse events are right. Sometimes I think fat events are right. Yeah, it's a difficult one. It's really, really nuanced. Now, fatter events combined with that metadata data pattern and versioning will ease the evolvability. And in some ways, it will reduce the runtime coupling because you reduce the need for them callbacks for systems to actually make a request back to the producer. Sparse and notification events are great for things that are actually notifications. Ask yourself the question, if you were to completely block all callbacks for a given event, would that still be okay? And if it is, then you can probably default to more thinner events. But if you are calling back every single time, that is going to increase your coupling. The trade-off being with fatter events, you need to manage this semantic coupling. You need to manage things like versioning and breaking changes, and that can be a lot of work, which might make you think, well, just long live the sparse event. This is easier. We only ever publish sparse events and we just deal with it. To take this to the absolute extreme, you could only ever publish events that include identifiers. So you see here, my order processing service is publishing an order confirmed event. It's got an order ID, and we block any callbacks. We stop the delivery service being able to call back. This is idealistic. This is impractical. I don't recommend you actually do this, but there is actually some interesting things you can get into here. You could only ever include identifiers, but just include a wider range of identifiers. So you've still got a relatively sparse event here. You've not got all possible data related to the order. And if you think about the core principles of microservices, that each service owns its own data, well, here the order processing service is keeping control of the order data. And if you think about this approach from a logical flow of a user ordering a pizza, you imagine now you've got your phone out, you're ready to order a pizza for your lunch or for your dinner. And the first thing you're going to do is add your delivery address to your account. So now the delivery service has your delivery address stored, and it has some kind of identifier, whatever that might be. And then at the point you submit your order, well, now you're going to submit the order information. And along with that, you're going to submit the delivery ID that you've selected. So now the order processing service can keep control of the order details. The delivery service owns the delivery details. And when the delivery service receives this order confirmed event, it knows exactly where it needs to get a delivery driver to go to because it has all that information. The core thing I want you to take away here with this sparse versus fat event carried state transfer versus notification events is however you do it, make sure you embrace some kind of metadata data pattern or the cloud event specification, something where you can include metadata along with your events, because that's what's going to allow you to stay evolvable over time. One of the big things you'll need to embrace as you start to build event-driven architectures is asynchronous systems. Every part of your system is now interacting in an asynchronous way. And if you're a developer used to making HTTP calls or method calls and just sitting there waiting for a response to come back, this is going to be a paradigm shift. For me, this took me a long, long time to get my head around. Now your service is doing a piece of work, maybe storing some data and then publishing an event. And then maybe, possibly at some time later, something else might happen. If we consider this same flow, the order confirmed event gets published, and maybe at some point later, hopefully for you, if you've ordered the pizza, that the order cooked event comes back to your order processing service. There's no way you can know that that is ever going to come back. There's no way to know, in fact, that the order confirmed event was actually received by the kitchen service. So one of the challenges you get into when you start building more asynchronous systems is one of consistency. You're going to have to start dealing with eventual consistency. And there's two types of consistency, strong and eventual consistency. And to walk you through the difference between the two, I actually want to go back to the pizza restaurant. And I want you all to imagine for a second that you've ordered a pizza. I apologize in advance if it's close to a mealtime for you. This normally makes people zone out a little bit. So sorry, please come back. Imagine you've ordered your pizza, you're going to the pizza shop to go and pick up the pizza. You walk in, the smell of pizza hits you in the face. You can see all the pizzas being made behind the counter. You think you can see your pizza being boxed up. You can almost taste it. You're so excited. And there's one thing you need to do before you walk out with your pizza. Of course, you need to pay for it. You need to give these lovely people who've given you delicious pizza some money for their services. And at this point, you have two options for how you pay. The first thing you could do is you could pay with cash, something that's becoming less and less common nowadays. But you could take out your purse or your wallet, take some money out of that wallet, hand that over to the cashier. They put it in the till, you get your pizza and go on your merry way. And this is an example of a strongly consistent transaction. It's strongly consistent because you can absolutely guarantee at this moment in time that the money has changed hands. It's no longer in your purse or wallet, and it's in the cashier, in the cashier's till. If you think about making a REST API call, at the moment you make the call, you can absolutely guarantee if that call succeeded or not, if it was received or not. If you think about the second option you have, which is to pay with your credit or debit card, all you're doing when you pay with a card is making a theoretical guarantee that at some point, maybe in the future, that money is going to go from your bank account to their bank account. I'm sure you've all been there where you've paid for something. Imagine you're in the pizza restaurant, you tap your card, you get your pizza, you walk out, get in your car, you look at your bank statement, and actually you then realize you've just got that pizza for free because there's no money come out of your bank account. Hooray, free pizza. And then, of course, at some time later, that money is going to leave your account and it's going to hit the account of the pizza restaurant. That is an example of an eventually consistent transaction. Over time, eventually, things will become, the state will become consistent across multiple places. And that's typically what you have to deal with event-driven systems. You're just publishing events, and at some time in the future, downstream systems are going to react to them and maybe publish events back. And there's no real good way around this. You need to embrace eventual consistency. You need to be aware of it. And as many of you are probably aware, architecture is simply just balancing a whole bunch of different trade-offs. And this is one of the trade-offs you're going to need to make as you adopt more event-driven systems. So one of the biggest challenges you're going to hit as you adopt event-driven architecture is around observability. Something blows up, something goes wrong. How the heck do you work out exactly what's going on? Cause and effect is really difficult in event-driven systems because remember, producers are just publishing events with no idea and frankly, no reason to care about who's consuming them. So you really need to think about how you're going to observe your event-driven systems. And one of the really simple ways to do this is to come back to that same schema pattern from earlier. As part of the metadata you include some tracing information. If you're using OpenTelemetry, that might be traces IDs and span IDs. If you're not, that might just be a correlation ID. The important thing here is to have some common piece of data that's passed from system to system. And then you can include that common piece of data in your structured logging or in your distributed tracing. And it gives you that ability to understand how systems are interacting with each other. And where this gets really interesting when we think back to that versioning conversation from earlier is that if you're consuming systems, as well as including the correlation ID, they also include the version of the event that they consume. It gives you the potential as a producer to be able to actually go and see how many systems are consuming your events. Distributed tracing, observability, understanding cause and effect is really, really important in event-driven systems. I put it second only to the design of your schemas. And the final thing I wanted to close out with today is around synchronous communication, the boundaries of your system. One of the most common things I get asked when talking about EDA is, if my entire system is driven by events, what happens when my front end application needs to talk to my back end? Because my back end only understands events, and my front end is just a React application that only understands HTTP. I think an important thing to take away is that you don't necessarily just need to have asynchronous communication everywhere. One of my favorite patterns when building event-driven systems is to have a really thin API layer, a synchronous API layer at the boundaries of your system. This might be where your front end makes requests into your back end. It might be, if you're building a SaaS product, this might be an API you expose to developers of your product. And this API might perform a really small amount of validation before storing data in some kind of database and then going off and publishing an event. So there's no actual real business logic happening here. Instead, you're just validating the request that's coming in, getting a response back to the caller, publishing an event, and then all of your business logic happens based on them events that get published in downstream systems. So it's commands and queries that come into the boundary of your system and events that get published off the back end to actually trigger the real work of your system. And I've used 3 different words there: commands, queries, and events. So let's just quickly understand what these 3 things are. Commands and events are pretty similar. It's mostly just the statement of intent that makes them different. With a command, I'm telling a given system to do some work. With an event, I'm reacting to something that another system has published, a change of state in another system. And you might have elements of both in your system. Your front end communicating with your back end might be a command over a synchronous HTTP request. Your order processing service communicating with your payment gateway, where you want to absolutely make sure that you don't start cooking pizzas that haven't been paid for, that might be a synchronous command-based communication. But everywhere else, you default to events and using events. And then queries, of course, queries are about retrieving data. Your front end needs to display a list of orders. Your kitchen needs to see all the orders that it needs to prepare. Queries are that way to get data out of your system. So just to finish off now, let's round all of this out. Let's stitch all of this together and make this whole flow event-driven. So at the edge of your system, you have your submit order request coming in from your front end, and that goes off and publishes an order confirmed event off the back of that. Your kitchen service is interested in your order confirmed event, and you'll also notice that the order processing service is also interested in that order confirmed event, and that's so it can update some kind of read model, some kind of view model. Once the kitchen's finished doing its work, it publishes an order prepared event, which of course the delivery service is interested in to make sure that the person ordering this pizza actually gets their pizza. The order processing service is also interested in this order prepared event to go off and update some kind of read model, some kind of view store. And then, of course, when you get the status of the order comes in, when you're sat there furiously refreshing your app to understand where your pizza's order is up to, that can then read from this read model. It's a really high-level look at how an event-driven architecture can actually start to stitch together. So if you've heard this whole talk now and you're thinking, this sounds fantastic, James, but I'm dealing with an existing system. I've got something I'm already working with and I want to make it event-driven, but I don't really know how. My advice would be to start small. Don't try to make your entire system event-driven overnight. Pick an area, pick a microservice, pick a single bit of communication, get that right, and then scale up from there. And I was actually talking to somebody the other day about strategies for doing this, how to introduce an event-driven system into something that exists but isn't event-driven today. And one of the things you can do is to actually start introducing events before you actually go fully event-driven. So even though you're still communicating over HTTP between your services, you could still get your services to start publishing events. And even if for a period of time, these are really sad events because nobody's actually listening to them, the fact that you've got the events there then gives you the possibility to start looking at places to make things more event-driven. So remember, event-driven architecture is fundamentally a communication pattern. And that's both the technical communication between your systems and the human communication as you bring the language of your business into your system. One of the hardest things in software development is communication. The language that you use to talk about your system between technical and business people is really important. If all your technical people are talking about REST APIs and microservices and gRPC, business people, non-technical people are going to turn off. Remember, words and stories are the master key to human success. And given that, at least for the moment, software development is still a fundamentally human endeavor, that then pertains to the success of your system. So event-driven architecture gives you that language to talk about your system, and it does that in a way that reduces coupling, that increases extensibility. It does that in a really flexible way. Now, of course, it's not a silver bullet. There's no such thing in software. And what I hope you've taken away from this talk is some of the trade-offs that you have to make, some of the pitfalls, and some really practical patterns that you can take away and use as you start building event-driven systems. We've definitely got time for questions. Thank you all very much for taking your time out of your day or evening for listening. I've got a whole lot of content on YouTube and talk about this on Twitter a lot. So yeah, thank you all very much.
That was really good, James. Like I can't think of a better primer for event-driven architectures. And like that wasn't even just like a top level primer. That was like 2 to 3 steps down. I have my sticky note here that I was preparing questions for you for the end, and you answered like literally every single one. Like you would go and talk about something, and then you would dive in on that topic. It was amazing. I do have questions, but I actually want other people to give other people the opportunity first. But just wanted to say, great job. That was awesome.
Cheers on.
I guess I will ask my question then. Uh, So I'm a big fan of, when making pitches like this to say, yes, this is how you get started. And you said start small. And then specifically you said start small by adding a messaging service. Now
Mhm.
let's start with a simple question that people may or may not know when we're talking about event-driven architectures. Can you publish an event without subscribers on the other end?
Yeah, absolutely.
What happens to that? Like what am I doing when I'm just pushing something out into the ether? Is that okay? Is that safe?
Safe in, it depends what you're putting in the event, is the number one thing I would say. So if you've got a whole lot of personally identifiable information in that that you might not want to expose publicly, then you probably don't just want to be throwing that around blindly. Absolutely not. But until you've got events flowing around, it gets really difficult to actually start adding event-driven communication, right? So I suppose what I'm getting at there is if you can start adding eventing to a system before you go fully event-driven everywhere, it gives you the potential to be able to start doing that. Taking the example of, I know I said this wasn't a talk about specific services, but talking about Amazon EventBridge. If you publish an event into an EventBridge and there's no subscriber, it will just get dropped. There's no subscriber there.
So you mentioned PII, personally identifiable information. Should you ever be publishing something like that in an event?
It depends on
That's
the use
not
case.
that's not even like a trick
Depends.
question. I'm
It depends. I got it
legitimately
in there.
asking you.
Woohoo!
I think Andres and I have had, hours and hours of conversations around this, and we always ended up on thin events because the data that we worked with was criminal justice data, and you
Yeah.
can't really pass information around with CJI.
Yeah, absolutely. What I mean, one of the really nice patterns I've seen for this is to, in essence, have two types of bus in your system. So you have a bus that any old person can go and subscribe to. Ben could subscribe to, Martin could subscribe to, Kelsey subscribe to, and then you have a second bus, which is like a PII bus, if you will. And you can then control that with IAM to say, okay, I don't know, only Ryan's allowed to subscribe to events on this PII bus. Now, of course, something like criminal justice data, I'd probably be very, very careful with that. But in other cases, that might be it's a strategy that I've seen work really well, is that you kind of just separate the data and you control it at an authentication level as opposed to a data level, if that makes sense.
Yeah, James, but there's always this issue that someone might add and extend this event, right?
Absolutely.
It's something
Yeah.
that is tricky, which brings us to the topic of the contracts, I guess, in the event-driven systems. What do you think
Yeah.
that are the best options to preserve the contract?
When you say preserve the contracts, to ensure that people are actually doing the
Yep.
thing that they said they would do.
Yeah.
Blind trust and hope. One of the things, I mean, I've seen some really nice patterns with this around actually building it into your testing pipeline, your integration tests. So
Mhm.
there's some samples we have on GitHub. I can probably find a link to them somewhere, where as part of your integration test, you will actually use some kind of schema registry. So let's say EventBridge schema registry for argument's sake. You, as part of your integration test, you pull down the latest version of your schema. You run your integration test, but you publish the event into memory, if you will, as part of your integration test. Then you can actually compare the schema of the two events. So it depends how trustworthy, I suppose, you are with your teams. Like there are, you can go to the whole hog and have it in tests. And you can do the same at a consumer level. Like I'd always say at a consumer level, be really defensive with how you program. Like consider the fact that it might change at any time.
Yeah, contract test on the producer is super important. And I've seen that work really well, where it's like if you're anything you're publishing, even if it's an HTTP and API, right? API it's the same thing as a message. If you've got a contract that's on the wire, whether it's synchronous or asynchronous, the producer needs to be responsible for guaranteeing that it's not breaking its contract or at least correctly versioning its contract if it's moving it forward.
That is like an hour-long conversation in itself, Ben, because you could make a lot of cases for it's also something that the subscribers or the consumers should be doing as well, making sure that that contract is what it expects to be when it comes over the wire.
Yeah, I tend to kind of go where James went is all of my consumers are as defensive as possible for a lot of reasons. But yeah, you could extend that across all those boundaries. On the security one too, another pattern that I've seen is passing around. So the thin versus fat event is an interesting discussion. If it's a closed ecosystem, fat events don't seem to be a trouble as long as data is encrypted, right? Even at rest and at transit. I don't see a whole lot of difference between a service talking over an API that's like using, mutual TLS versus an event that's going through SQS and going through EventBridge that's also encrypted at rest and encrypted at transit. And again, if it's closed, if it's going to be something that's going to go out to like an API destination through EventBridge, that's a completely different conversation.
Would you don't have to tell me if you've done this or not, Ben, but I know
can.
you come from the healthcare background. So would
Yeah.
you pass like HIPAA data across an event?
Closed ecosystem, yes. Public ecosystem, no. Some examples of some things that anything that I know that's working interoperable between external systems, thin events, right? Key values, something that you can go back and fetch later. A nice pattern with that is using AWS's Health Lake as a fire resource server. So sending the identifier and the entity that's being passed over, the consumer can then go ahead and turn around and say, oh, okay, give me patient or give me encounters, give me whatever. Internally, if it's between a closed ecosystem and I know that the events are going to happen between, let's say, a patient portion and a visit or a patient and a medication, yeah, I don't have an issue with that as long as everything in the chain is encrypted, and then I can grant access based on who can decrypt and encrypt with that KMS. I'm not saying I've done all of those things, but there's a high likelihood that I have. And there's a person on this call that could probably verify some of it because I see Scott down there lurking. So Scott may have actually seen some of that. But
You don't need to confirm or deny it.
I plead the fifth.
We're not physically connected by FTE status anymore, Scott. You don't have to plead the fifth at this point.
You're a friend. I plead the fifth.
Okay, there we go.
So, James, I have another specific question. So we're talking about how do you get started and actioning. I'm going to go back to what you said, what I said that you said. Start small, add a messaging service. Now, I know from experience, I know one of the hardest things that you can do is figure out like what are these business events? What should I be triggering on? And one of the hardest problems in computer science is naming things. What should I call them? How do you do that? Because that's not a developer's call generally, what these events are. What's the process that people normally go through to identify what these events are and subsequently name them?
And that's one of the important things, to align things across business and technical. The tool I always reach for in this space is event storming. So event storming is something popularized by Alberto Brandolini. And there was kind of an image in the deck that kind of alluded to what event storming is, the one where you had all the people and all the sticky notes that people are stuck on a screen. And what you typically do in event storming is you get a whole lot of people in a room, technical and non-technical, importantly. It's not just developers, it's developers and business people. And you'd all start by agreeing, there's probably a whole other talk here, Alan, to be honest, but you'd start by agreeing what all the events are that you might see across the system. If you've got things that are similarly named by, say, me and you, Alan, you think order confirmed, I think order completed, you group them together and kind of agree what the right terminology is, and you get that agreement in place across the technical and non-technical people. If you find two developers who are diving into Kubernetes or not Kubernetes, then the answer is always not Kubernetes napkin. You pull them back, get them out of that, get them out of the technical stuff, get them into the business stuff. And it's about a business conversation about the business events. And then you get into what commands trigger the events, what queries are needed to service the views that would then allow people to run the commands, and it's a whole thing. But that's the tool I'd reach for. There's a whole lot of good resources online about event storming. That's where I'd start.
So give us the cliff notes of that. So I've done event storming, and it is as fun as it is exhausting. I think, Andres, we've done them several times across a set of like 3 days, like 8-hour sessions for 3 days in a row. And you end up with something like 200 sticky notes in like 6 different colors, representing a whole bunch of different things. So let's cliff notes from there, because that was actually the hardest part for me. That first part is great for learning and getting on a level playing field between the technical people and the product people and the business people. And then turning that into action items. Like, how do I go from, yes, I've identified what the business is, to hands-on keyboard? What's the next step after you event storm?
I think it depends. Are you building something net new, or are you building something inside an existing system? If you're building something inside an existing system, I'd look at where the events logically sit. Let's say you're already building microservices. Let's stick with this pizza example. Okay, all the events that are related to the order, you kind of push them towards the order processing service, and you kind of group things up by service. That then breaks that down into like, this is your job, Alan, this is your team's job, Marcin, this is your team's job, Andres, this is your team's job. From there, I'd actually get into, if you're going to have, like you said, lots of different things. You're going to have commands and queries and events. To actually get the event to be published, you're going to need the command to come in first. Typically, you're going to need to build the command. You're going to need that interface to then start publishing the event off the back of that. There's probably a step before that, actually, thinking out loud. Once you get into the individual teams, you want to get to the schema, the event first design first. You want to understand what's actually going to be in that event. When you first finish event storming, you're just going to have order confirmed, payment failed, blah, blah, blah. So you want to understand what is actually going to be in that event, what's the contract of that event, and then you'd probably get into the thing I described before. I do that after. Can we do some cool editing there and like spin things around so it sounds like I know what I'm talking about?
I'm thinking that regarding event storming, I think that the biggest value is that you understand, Alan, like your business, and they understand you, how the system works, what events might be, right? But regarding as an outcome of the event storming, also you should have like regarding implementation, right? You have commands and events identified, and as well actors, right? So this implementation is kind of, should be, right, straightforward. Of course it's not, right? But everyone will be doing event storming, and I guess it's not the common practice, but that's super common practice. But I understood, like, Alan, your question regarding the naming of the events a little bit differently. I thought that you were asking more about the naming conventions for the events. This is something that is quite important, I think, as well. Like, I remember that when I was building a couple of systems, I was naming events with just domain names, let's say. But when I saw in some book that people are adding the prefixes to the event names, like it looks like more like a package to inform which system it comes from and this kind of thing. But I'm not sure what are the best practices, James, in your opinion on that.
Could you just repeat the last bit of that? Sorry, Marcin.
Yeah, so when you have event name, that something had happened, right?
Mm-hmm.
So what people tend to do is that, for example, I don't know, pizza ordered, right? But sometimes it might be like some, let's say, kitchen, pizza ordered, right? So you have the information that, for example, with the package, or I don't know, some source of the event, right? So what are the best practices in your opinion on that?
So if you've got all the additional metadata in there, I like to keep the actual type of the event as close to the business language as possible. So try and keep that as close to order confirmed, order completed, pizza box, whatever. But as part of that metadata that you publish, you would include some additional stuff like the source system, for example, or the source environment. So then you could build that com.prod.orders.order confirmed. You have all that same data, but you keep the actual event name as close to the business language as possible to help that mapping as much as possible. Because then if somebody looks at that, they're like com.order.what.prod, whereas order confirmed. Nice and simple, we know what that is.
Okay, yeah, it makes lots of sense. I'm thinking that I always name them with the domain names, so I think that it's more understandable. And I think that it also might be better for the filtering in stuff like Event Bridge, for example, right?
Yeah, and I mean with having the name, so that orders.order confirmed, I suppose, is what you mean there. I assume.
Yeah.
That would be the name of the event. Yeah, because you might have a place where I don't know, I'm thinking about what's the word for it in domain-driven design, where you have like a user in one domain and a user in another domain, but they're actually
Ubiquitous
different.
language, I
Ubiquitous
guess.
language, that's the one. You might have that similar situation. So actually having orders dot and kitchen dot then might be useful if you've got two events that have a similar name, but they actually kind of mean different things.
Yeah,
I mean,
but
I'll
I'm right
probably
now
try and
thinking
name them.
what might be the reason that people are using it, and I have like one idea. Like sometimes you can put a filter, for example, on SMS or something, and it has limited amount of the attributes. Yeah, and then remember it was 5, I guess, back in the days. Maybe that's why people are doing that, so they can do some. Okay.
I mean, I definitely don't think it's a bad. Like having the data somewhere is the important bit. I think, like whether you do it as part of the whole event name or as separate fields in your metadata, like there is some technical limitations there, like you said, whether your message transport supports it or not. But I think having it is the important thing. And if you happen to need to name your events com.prod.orders.order confirmed, then that's fine. There's ways to work with that.
Okay, we have time for one more question, and it wins. This question comes from the chat, and it wins the "It Depends" award of the day. So I'll go ahead and read it for you. How do you decide on having a single broker versus multiple brokers? Knowing full well that it depends on the cloud provider, such as, are you going to have a broker for every account and region combo? But is there any tips that you have on an approach to deciding one versus N?
Putting technical limitations aside, as in like the region and account stuff, and I always like to start as simple as possible. Start with as few moving parts as possible as you can. If you're just getting started building an event system on AWS, typically a single central event bus will be enough to get you started. If you've got like the PII use case that I described, you've got a specific business reason to start separating things. That'd be one reason to separate it. And then as you start to scale, you're going to start hitting service limitations around many of these buses, which means you will need to separating things out. And then I'd probably start looking at having an internal bus within a domain. So you'd have like the orders bus, the payments bus, the kitchen bus, and then multi-tenancy. Interesting one, actually. Hadn't considered that. That's a good point.
Don't dive into that because we're out of
Yeah.
time, and that can go for a long
Drop me a
time.
message on the Discord or on let's continue this in Discord. Yeah, multi-tenancy is a really interesting one, actually.
Yeah, so let's bring that one into the Discord. I actually want to participate in that one. That's going to be a good conversation.
Great job, James.
Yeah. So thank you, James. This was super great. Fantastic way to kick off the EDA month. Next week, I'm going to apologize in advance. I don't remember how to say your name properly. I'm going to say Zied.
Correct. That's correct.
Yes. All right.
Yes.
So we have Zied next week, who's going to be walking us through an event-driven generative AI video summarizer that he built. So it's a practical use case of event-driven architectures in action. So I know that the time this week kind of threw some people for a loop. So I'm just going to say it ahead of time. Next week is the same time. So we are having this one next week a couple hours earlier than normal, just like today. So looking forward to it. And again, thank you, James. Fantastic.
Thank you for having me. It's been a lot of fun.